Hello, welcome to ITEXPS YouTube video series. Today we are going to talk about supervised learning versus unsupervised learning. What is supervised learning? Supervised learning is a machine learning approach that's defined by its use of labeled datasets. These datasets are designed to train or supervise algorithms into classifying data or predicting outcomes accurately. Using labeled inputs and outputs, the model can measure its accuracy and learn over time. Supervised learning can be separated into two types of problems when data mining: classification and regression. Classification problems use an algorithm to accurately assign test data into specific categories, such as separating apples from oranges. Or, in the real world, supervised learning algorithms can be used to classify spam in a separate folder from your inbox. Linear classifiers, support vector machines, decision trees, and random forest are all common types of classification algorithms. Regression is another type of supervised learning method that uses an algorithm to understand the relationship between dependent and independent variables. Regression models are helpful for predicting numerical values based on different data points, such as sales revenue projections for a given business. Some popular regression algorithms are linear regression, logistic regression, and polynomial regression. What is unsupervised learning? Unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled datasets. These algorithms discover hidden patterns in data without the need for human intervention, hence, they are unsupervised. Unsupervised learning models are used for three main tasks: clustering, association, and dimensionality reduction. Clustering is a data mining technique for grouping unlabeled data based on their similarities or differences. For example, K-means clustering algorithms assign similar data points into groups, where the K value represents the size of the grouping and granularity. This technique is helpful for market segmentation, image compression, etc. Association is another type of unsupervised learning method that uses different rules to find relationships between variables in a given dataset. These methods are frequently used for market basket analysis and recommendation engines, along the lines of customers who bought this item also bought recommendations. Dimensionality reduction is a learning technique used when the number of features or dimensions in a given dataset is too high. It reduces the number of data inputs to a manageable size while also preserving the data integrity. Often, this technique is used in the pre-processing data stage, such as when autoencoders remove noise from visual data to improve picture quality. The main difference between supervised and unsupervised learning: labeled data. The main distinction between the two approaches is the use of labeled datasets. To put it simply, supervised learning uses labeled input and output data, while an unsupervised learning algorithm does not. In supervised learning, the algorithm learns from the training dataset by iteratively making predictions on the data and adjusting for the correct answer. While supervised learning models tend to be more accurate than unsupervised learning models, they require upfront human intervention to label the data appropriately. For example, a supervised learning model can predict how long your commute will be based on the time of day, weather conditions, and so on. But first, you will have to train it to know that rainy weather extends the driving time. Unsupervised learning models, in contrast, work on their own to discover the inherent structure of unlabeled data. Note that they still require some human intervention for validating output variables. For example, an unsupervised learning model can identify that online shoppers often purchase groups of products at the same time. However, a data analyst would need to validate that it makes sense for a recommendation engine to group baby clothes with an order of diapers, applesauce, and sippy cups. Supervised versus unsupervised learning: which is best for you? Choosing the right approach for your situation depends on how your data scientists assess the structure and volume of your data, as well as the use case. To make your decision, be sure to do the following. Evaluate your input data. Is it labeled or unlabeled data? Do you have experts that can support additional labeling? Define your goals. Do you have a recurring, well-defined problem to solve? Or will the algorithm need to predict new problems? Review your options for algorithms. Are there algorithms with the same dimensionality you need: number of features, attributes, or characteristics? Can they support your data volume and structure? Classifying big data can be a real challenge in supervised learning, but the results are highly accurate and trustworthy. In contrast, unsupervised learning can handle large volumes of data in real time. But, there is a lack of transparency into how data is clustered and a higher risk of inaccurate results. This is where semi-supervised learning comes in. Real-life applications of supervised learning. Risk assessment. Supervised learning is used to assess the risk in financial services or insurance domains in order to minimize the risk portfolio of the companies. Image classification. Image classification is one of the key use cases of demonstrating supervised machine learning. For example, Facebook can recognize your friend in a picture from an album of tagged photos. Fraud detection. To identify whether the transactions made by the user are authentic or not. Visual recognition. The ability of a machine learning model to identify objects, places, people, actions, and images. Real-life applications of unsupervised learning. Market basket analysis. It is a machine learning model based on the algorithm that if you buy a certain group of items, you are less or more likely to buy another group of items. Semantic clustering. Semantically similar words share a similar context. People post their queries on websites in their own ways. Semantic clustering groups all these responses with the same meaning in a cluster to ensure that the customer finds the information they want quickly and easily. It plays an important role in information retrieval, good browsing experience, and comprehension. Delivery store optimization. Machine learning models are used to predict the demand and keep up with supply. They are also used to open stores where the demand is higher and optimizing routes for more efficient deliveries according to past data and behavior. Identifying accident-prone areas. Unsupervised machine learning models can be used to identify accident-prone areas and introduce safety measures based on the intensity of those accidents. Interview question and answer. What are the two types of problems solved by supervised learning? Supervised learning can be separated into two types of problems when data mining. Classification. It uses algorithms to assign the test data into specific categories. Common classification algorithms are linear classifiers, support vector machines SVM, decision trees, k-nearest neighbor, and random forest. Regression. It is used to understand the relationship between dependent and independent variables. Linear regression, logistical regression, and polynomial regression are popular regression algorithms. Give a real-life example of supervised learning and unsupervised learning. Supervised learning examples. You get a bunch of photos with information about what is on them and then you train a model to recognize new photos. You have a bunch of molecules and information about which are drugs and you train a model to answer whether a new molecule is also a drug. Based on past information about spams, filtering out a new incoming email into inbox normal or junk folder spam. Cortana or any speech automated system in your mobile phone trains your voice and then starts working based on this training. Train your handwriting to OCR system and once trained, it will be able to convert your handwriting images into text till some accuracy obviously. Unsupervised learning examples. You have a bunch of photos of 6 people but without information about who is on which one and you want to divide this dataset into 6 piles, each with the photos of one individual. You have molecules, part of them are drugs and part are not but you do not know which are which and you want the algorithm to discover the drugs. A friend invites you to his party where you meet totally strangers. Now you will classify them using unsupervised learning, no prior knowledge, and this classification can be on the basis of gender, age group, dressing, educational qualification or whatever way you would like. Why this learning is different from supervised learning. Since you didn't use any past prior knowledge about people and classified them on the go. What is k-nearest neighbors algorithm? K-nearest neighbors is a supervised machine learning algorithm that can be used to solve both classification and regression problems. It assumes that similar things are closer to each other in certain feature spaces, in other words, similar things are in close proximity. The image above shows how similar points are closer to each other. KNN hinges on this assumption being true enough for the algorithm to be useful. There are many different ways of calculating the distance between the points, however, the straight line distance Euclidean distance is a popular and familiar choice. What is bias in machine learning? Supervised machine learning: an algorithm learns a model from training data. The goal of any supervised machine learning algorithm is to best estimate the mapping function for the output variable given the input data. The mapping function is often called the target function because it is the function that a given supervised machine learning algorithm aims to approximate. Bias are the simplifying assumptions made by a model to make the target function easier to learn. Generally, Linear algorithms have a high bias, making them fast to learn and easier to understand, but generally less flexible. Examples of low-bias machine learning algorithms include decision trees, k-nearest neighbors, and support vector machines. Examples of high-bias machine learning algorithms include linear regression, linear discriminant analysis, and logistic regression. What is overfitting in machine learning? Overfitting refers to a model that models the training data too well. Overfitting happens when a model learns the detail and noise in the training data to the extent that it negatively impacts the performance of the model on new data. This means that the noise or random fluctuations in the training data is picked up and learned as concepts by the model. The problem is that these concepts do not apply to new data and negatively impact the model's ability to generalize. What is underfitting in machine learning? Underfitting refers to a model that can neither model the training data nor generalizes to new data. An underfit machine learning model is not a suitable model and will be obvious as it will have poor performance on the training data. Underfitting is often not discussed as it is easy to detect given a good performance metric. The remedy is to move on and try alternate machine learning algorithms. What is the difference between supervised learning and unsupervised learning? Supervised learning is when the data you feed your algorithm with is tagged or labeled, to help your logic make decisions. Example: a hypothetical non-machine learning algorithm for face detection in images would try to define what a face is: round skin like colored disk, with dark area where you expect the eyes, etc. A machine learning algorithm would not have such coded definition, but would learn by examples. You will show several images of faces and not faces, and a good algorithm will eventually learn and be able to predict whether or not an unseen image is a face. Unsupervised learning are types of algorithms that try to find correlations without any external inputs other than the raw data. Your examples are not labeled, i.e., you do not say anything. In such a case, the algorithm itself cannot invent what a face is, but it can try to cluster the data into different groups. For example, it can distinguish that faces are very different from landscapes, which are very different from horses. What is the difference between a regression problem and a classification problem? Classification is the problem of identifying which set of categories an observation belongs to. Regression is a set of statistical processes for estimating the relationships between a dependent variable and an independent variable. Classification is used to predict the values of a categorical variable, so the output is generally in the form of integers, or binary 0 or 1. Regression is used to predict a continuous variable, so the output is also a floating point number: 0.1, 0.74, 0.69. What's the difference between covariance and correlation? Covariance measures whether a variation in one variable results in a variation in another variable, and deals with the linear relationship of only two variables in the dataset. Its value can take range from. Simply speaking, covariance indicates the direction of the linear relationship between variables. Correlation measures how strongly two or more variables are related to each other. Its values are between -1 to +1. Correlation measures both the strength and direction of the linear relationship between two variables. Correlation is a function of the covariance. How does k-fold cross-validation work? Imagine you have 1,500 labeled data points, and you want to estimate how well some classifier will work on new data. What you do with no cross-validation. Let's say you decided to train the model with 1,000 of your examples, and evaluate with 500. Note that we only have predictions for the 500 test samples, so our model performance estimate is overly optimistic. Why? Because accuracy obtained for one test set can be very different to the accuracy obtained for a different test set. What you do with cross-validation.
Let's set k equal to 3, so the data is split into 3 sets of 500 points A, B and C.
Use A and B to train a model, and get predictions for C with this model. Use B and C to train a model, to get predictions for A. Finally, use A and C to train a model, and get predictions for B. Now we have a prediction for every point in our labeled data that came from a model trained on different data. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you in resume LinkedIn. Staffing support. Provide tech references. In-person online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.